Okay, today we are on chapter 4.7, day 9 notes. This is going to be graphing rational functions. So we have a couple components of the graph. First, we have branches. This is going to be the portion with ordered pairs. Okay, and then we are going to have our asymptotes. We can have vertical, horizontal, or slanted asymptotes, and our slanted asymptotes are called oblique. All right, so we are going to first have 4 different cases. I am going to label this as A, B, C, and D. I just think it'll be easier when we go through the examples. We can refer back to example A, B, C, D, and so forth. So in example A, we have y equals ax plus b over cx plus d. So if you notice, this is equal degrees. So we both have, in this example, x to the first power. Okay, but this could be the same if we had like 2x cubed on the top and 4x cubed on the bottom. That would still be like example A, where the degrees on the top and the bottom are the same. So when this is the case, our horizontal asymptote is going to be equal to A over C. So again, if that was, as an example, 2x cubed over, I don't know, don't like that example, over 3x cubed, then our horizontal asymptote would be 2 over 3, okay? Our next example, we have y is equal to a over x minus h plus k. So in a scenario like this, where that exponent is on the bottom, our horizontal asymptote is going to be y is equal to k. So whatever that constant is out on the side. All right, example C. We have y equals ax to the first plus b over cx to the nth power plus d. And that is where n is greater than 1. Because if it was 1, then we'd be back to example A. So we just have to specify that that needs to be greater than 1. So if that is the case, so if we have the larger exponent on the bottom, then our horizontal asymptote is going to be equal to y equals 0. Okay. And then our last case, example D, we have y is equal to ax to the n power plus b all over cx plus d. And again, n is greater than 1. So this is just the reverse of C. So when this happens, there is no horizontal asymptote, but we will have an oblique asymptote. So no horizontal asymptote. There will be an oblique asymptote. Example 1, we have y equals -2 divided by x minus 3. So looking at the above chart, this one matches our example B. So our horizontal asymptote is going to be y equals k. So this one is plus 0, so just y equals 0. Then to find our vertical asymptote, we're just going to set the denominator equal to 0, so x minus 3 equals 0, so x equals 3. Okay, next we can go ahead and identify our x and y intercepts. So my x-intercept, I'm going to set y equal to 0. So 0 equals -2 over x minus 3. This would not be possible because if I multiply both sides by x minus 3, I'm going to get 0 equals -2. That is not true, so there are no x-intercepts. Then I can go ahead and find my y-intercepts. So I'm going to set x equal to 0. So I would have y is equal to -2 over 0 minus 3. So y is equal to 2/3. So it's going to be 0, 2 over 3. Okay, so I can go ahead and plot these points first. So my horizontal asymptote is going to be at y equals 0. My vertical asymptote is at x equals 3. Okay, then I know my y-intercept is at 0, 2/3. It's like right about there. Okay. So this side is going to look like this. And then to determine what the other side is going to look like, I am just going to plot, or I'm just going to substitute in a value. So we have 1, 2, 3, 4. So let's put x as 4. So I would have y is equal to negative 2 over 4 minus 3, which would be negative 2 over 1. So y is negative 2. So at 4, negative 2, that's another point that we can plot. So 4, negative 2. So then because I know where my asymptotes are, the rest of the graph will look like this. Okay, looking at example 2, we have y equals 4x minus 2 divided by 2x plus 1. So again, if we look at the top chart, that looks like our example A. So I'm going to look at the coefficients in front of the variables. Since 4x and 2x both are linear, they both are to the power of 1. So I know that my horizontal asymptote is going to be y is equal to 4 over 2, which just simplifies to 2. And then to find my vertical asymptote, I set the denominator equal to 0 and solve for x. So x is going to be equal to negative 1/2. Okay, now we can solve for our x and y intercepts. So first let's go ahead and solve for our x-intercepts. So let's set 0 or y equal to 0. So 0 equals 4x minus 2 divided by 2x plus 1. Multiply both sides by 2x plus 1 and we get 0 is equal to 4x minus 2. Solve for x. 2 is equal to 4x. So then 1/2 is equal to x. So my x-intercept is going to be 1/2, comma 0. And then to find our y-intercept, we make x be 0. So I have y is equal to 4 times 0, which is just 0, so negative 2 over positive 1, which is equal to negative 2. So my y-intercept is going to be 0, negative 2. Let's go ahead and plot that. So my horizontal asymptote is y equals 2. My vertical asymptote is at x is negative 1/2, so negative 1/2. My x-intercept is at 1/2, 0. And then my y-intercept is at 0, negative 2. Okay, so the right-hand side of this graph, we have some points, so we can just connect them. We know what this is going to look like. To find out what the left-hand side is going to be, let's just substitute in a value. So I'm going to choose negative 1. So let's let x equal negative 1. So then y is equal to 4 times negative 1 minus 2 divided by 2 times negative 1 plus 1, which is going to give us negative 4 minus 2 all over negative 2 plus 1. So y is equal to negative 6 over negative 1. So y is equal to 6. So when we are at negative 1, we'll be at positive 6. So then I can go ahead and finish the left-hand side of this graph, and that's what the graph would look like. Okay, number 3, we have y equals negative x divided by x plus 2 times x minus 2. So this one's a little less obvious. The degree in the numerator is going to be to the power of 1, but the degree in the denominator, if we were to double distribute, the degree would be 2. We would have x squared. So if we look back at our table at the beginning, we have the larger power is in the denominator. So this would follow example C. So that means that our horizontal asymptote is going to be y equals 0. Okay, to find our vertical asymptotes, we set our denominator equal to 0. So I would have we're going to have two vertical asymptotes. One will be at x equals -2, and then the second would be at x equals +2. Okay, let's go ahead and find our x-intercepts. So my x-intercept happens when y equals 0. So I have 0 is equal to -x over x plus 2, x minus 2. If I multiply both sides by the denominator, I'm going to get 0 is equal to -x. So that just means 0 equals x. So I will have a vertical or a x-intercept at 0, 0. Then we can find our y-intercepts. So that's going to be y is equal to -0 all over 2 times -2. So it would be 0 over -4, which of course just equals 0. So my y-intercept would be 0, 0 as well. So my horizontal asymptote at y equals 0, put that in. I'm going to use a different color. There we go. Okay, then my vertical asymptotes at x equals -2, and then x equals +2. Okay, and then the only point that we know is 0. So we are going to have to make a table to test some different values. So I'm going to have my x. So you're going to want to take out a calculator and y, and then I'm going to test some values on either side of those asymptotes. So I'm going to test -4. I'll test -3, -1, 1, 3, and 4. You can pick different values, but those are the ones I'm going to test. So take a second, pause the video, substitute those x values into the original equation, and fill out the rest of the table. Okay, so this is what the table should look like. If you pick the same values that I did, then you can go ahead and graph those points or plot the points. Okay, so your graph should look something like that. Number 4, y equals 3x divided by x minus 1 times x plus 3. So again, in the numerator, my degree is to the power of 1, and in the denominator, my degree is 2. So this again is like example C from our table up above. So my horizontal asymptote will be y equals 0. My vertical asymptotes, again, set the denominator equal to 0, so we will have x equals 1 and x equals -3. Next, we can find our x-intercept. So y will be 0, so we have 3x over x minus 1, x plus 3, multiply both sides by the denominator. 0 equals 3x, so 0 equals x. So my x-intercept will be 0, 0. My y-intercept will be y equals 3 times 0 is 0, all over -1 times 3. So my y-intercept will also be at 0, 0. So for this graph, I'm going to label it so it's a little bit spaced out. So I'm going to call this 1, 2, 3, 4, and 5. The same thing on the other side. And then the same with my y-axis. I'm going to jump up by 2s and going down. Okay, so I am going to have my horizontal asymptote at y equals 0. And my vertical asymptote, one will be at x equals positive 1. And then the second is at x equals negative 3. And then again, we are going to test some values. So I'm going to make a chart. And I'm going to test negative 5, negative 4, negative 2, negative 1, 2, and 3. So we do want to have at least 2 points on either side of the asymptote so we can get an idea of what the graph is going to look like. So again, substitute those values in using your calculator, and then unpause the video to check your answers. Okay, so hopefully your numbers came out the same as mine. Then we can go ahead and plot our points. Okay, at negative 2, I'm at positive 2. At negative 1, I'm at 3/4. And then here we're at 0, 0. Okay, at 2, I'm at 1.2. And then at 3, we're at 0.75. Okay. Moving on to number 5, we have y equals 3x squared over x minus 1 times x plus 3. So looking at our numerator, we have degree of 2, and looking at our denominator, we have degree of 2 as well. So when they match, that looks like our example A from the beginning. So we are going to be looking for our horizontal asymptote, looking at our coefficients. Okay, so my horizontal asymptote is going to be y equals, now if I were to double distribute, I would end up with x squared. So the coefficient would still be 1. So I would have 3 over 1. So my horizontal asymptote will be y equals 3. My vertical asymptote will be x is equal to positive 1 and x is equal to negative 3. Then to find my x-intercept, we'll substitute 0 in for y. Multiply both sides by the denominator, so we have 0 equals 3x squared. So x ends up being 0, so my x-intercept will be at 0, 0. My y-intercept, if we substitute 0 in for x, we'll have 0 over negative 1 times 3, so again, my y-intercept will be at 0, 0. I'm going to space this graph out as well, so I'm just going to call each tick mark, I'm going to go up by 2. And same increasing on my y-axis by 2. You don't have to do that, I just think it spaces it out a little bit better. Okay, so then I am going to have my horizontal asymptote at y equals positive 3. And my vertical asymptotes at x equals positive 1. And at x equals negative 3. Okay, and the only point that we know right now is 0, 0. So let's go ahead and make a chart to test some values. So I'll have my X, my Y, and I'm going to be testing -5, -4, -2, -1, 2, oops, I'm actually going to do 1/2 in here first, and then 2 and 3. And I'm choosing to do 1/2 because we know at 0, we're at 0, 0, but I'm not sure what's going to be happening in between 0 and our asymptote at 1. So go ahead, pause the video, substitute in your values, and then check your answers. Okay, then let's plot our points. So at -5, I'm all the way up here at 6.25, and then I just keep going higher, so I at least know which direction this graph is going. Okay, at -2, I'm at -4. At -1, I'm at -3/4. Then I'm at 0, 0. Then at 1/2, I'm back down here at -0.4. So I know that this is making like a parabola down here. Okay, then at 2, I'm at 2.4. And then at 3, I'm at 2.25. Okay, so you may notice that this one actually crosses the horizontal asymptote. Um, so this is a little bit of a special case. So to determine if that's going to happen, you are going to set, I'm just going to write down here, so set the equation equal to the horizontal asymptote. If your answer there, so if x equals some number, that's where it's going to cross the horizontal asymptote. If x is equal to plus or minus 3, which in this case is that asymptote right there, then it will cross twice. Okay, so this would be then cross once. All right, and then if x is, or sorry, if you get like no solution, so if you were to get 0 equals 4, something that doesn't make sense, then it would never cross. Okay, so if we test this out, we have 3x squared over x minus 1, x plus 3, and we set that equal to 3, then I end up having 3x squared is equal to 3 times x minus 1, x plus 3. So then 3x squared is equal to 3 times x squared plus 2x minus 3. We can keep solving. 3x squared is equal to 3x squared plus 6x minus 9. Okay, so then I'm going to have 6x is equal to positive 9. So x is equal to 3 over 2. So we did get this first option right here, x equals some number. So then it will be crossing. So at 3/2, that's where I'm going to be crossing my asymptote, which is right about here.